In this final video lecture of the course, I wrap up some loose ends in post-selection inference and round up. What we see implicitly, although we did not spend that much attention to it everywhere, was that most methods require you to estimate sigma squared, the variance. And typically, they require you to do that in a way that it's an estimate which is independent of the selected model. Now, in particular for POSI, this was really crucial to make the method work. So one way to do it is, well, suppose you have a full model, so you can say, okay, I look at the model where I include all variables, the full model, and that model is not too large, so n is larger than p, then you could estimate it from the full model. But what if n is smaller than p? Well, of course, that gives you a problem, because then you cannot use the full model to estimate it. And that makes a problem on coming up with a good estimate that is theoretically applicable in these kind of settings. Now, of course, we can estimate that from particular models, but that of course breaks the independence from selected models. Yet on the other hand, there's a paper which investigates this. In practice, it turns out that that actually works quite well in simulations. So just use, for instance, a lasso with cross-validation and use then the residual sum of squares to get an estimate of sigma squared. And even though, of course, that is dependent on a model, it turns out that the sensitivity actually of post-selection inference to that is very small. So that at least provides us with a practical solution to the issue of sigma squared, but estimating this is in a way an open issue and more theory is needed. Now let's wrap up then. Where are we? We had this table before, and then we said, well, for the lasso we've seen estimation, point prediction, variable selection. We said first we saw parameter inference, but now actually we know that using the oracle is not a good idea, but we also know that it is possible. There are ways to do parameter inference. Factor models we covered already before, so there's nothing new here in the table compared to when we last saw it. Now the open end here, of course, is this question mark here, prediction inference. Now, as I mentioned before, prediction inference is difficult because it requires you to come up with a method that can take the distribution of all parameters into account at the same time, because a prediction is a function of all your parameters. So this is something that is still pretty much an open issue, although there is some hope, because there are now methods both based on POSI and in particular one based on the sparsified lasso, which looks very promising, that have been proposed, and you can find the details for that paper on Canvas. So it does seem actually to be possible, although it's clear that more work is needed on that. So with that, we pretty much reached the end, and we have a good overview of all the things we can do with these methods, how we stand with inference, and so on. But I would like to raise one more point. So I've added some more question marks here for factor models. The theory is there. We know from Bayern in 2006 we can do inference on the parameters and on predictions and treat the factors as if they were observed. But all the uniformity stuff that we dealt with in the left column for penalized regression, is that something we don't need to take into account on the right hand side? So clearly there will also be some issue there with uniformity. What if you have factors which are so-called weak, which are more difficult to detect, and that may not even be in X, but it may actually be in the factor augmented regression for Y? Are we still able to make everything work then? It will obviously depend on where we do the selection. Like if we do selection in X, then the problems will mostly arise if factors are weak there, but strong in Y. If we do selection in the factor augmented regression, well, that will probably depend on how strong factors are there. Now, there's not that much theory about this, so this is also still an open issue. And it seems that in practice, yes, weak factors could be problematic. So, just to also, as a short reality check, unfortunately, or maybe fortunately, not everything has been definitely solved yet. So we've gotten quite a long way. So the current standing of the literature allows you to do many things, but there are still some things, of course, which remain open. Well, and obviously, if they remain open, they can also not be treated in this course. That brings me to the end of the lecture material that I wanted to discuss. And so this is the final video lecture of the course.